Some important things that you may have not known in C++ or programming in general, part 2. The first thing is for each loops. So what are for each loops? The for each loop is basically useful for iterating through list-like structures such as arrays or standard vectors. You are familiar with for loops and while loops, and you're also familiar with do while loops. But there's one other thing that's called for each loop. Now, the for each loop is especially useful for iterating through list-like structures such as arrays or standard vectors. Then you might ask, why would we prefer for each loops instead of the regular for loops? The reason is that for each loops provide a more convenient syntax. Now here I'm going to type in a for each loop. So first of all, let me have an int, and I'm going to call this as Fibonacci, and I'm going to specify the Fibonacci sequence in here. So I'm going to have 5, and I'm going to basically have numbers here. So it's going to start with 0, it's going to go 1, and then 2, basically 1, 2, and then we have 3 over here. Now this is an array of numbers, and these are 5 numbers. So this is basically this. Now I have to iterate through this. For a regular for loop, what we would basically do is we'd have int I is equal to 0, and then we'd have I is less than the Fibonacci size, which is 5 over here, so we just put 5 here, and then we'd put I plus plus. We could just spit out each element like this. So console output, and we could have Fibonacci, so we could say Fibonacci, and we could have the I index, the iterator, as the number to assign for the index. So this is how it's going to be specified using a regular for loop. For each loops provide a much more convenient syntax. So if I could basically write for, and then I could write int, and then I have to just specify a variable here. So I could say int number, and then I put a comma, and right after this comma I could write where I want to so the name of the array. So right now this is known as Fibonacci. That's all I have to tell. So a number will iterate through the entire array. So standard, and then basically I just want a console output, so I could just say console output, and I say number, and that's basically it. So over here you could see that this one and this one pretty much do the same exact task, but this one is just a better syntax. Now over here I could remove this brackets over here, and it would still work. Play button and run the code. So you can see over here 0, 1, 1, 2, 3. And why is it 1, 1? Because 0, 1, 1, 2, 3. And that's how it works. Now what's so cool about this for each loop is that there's this counter variable, which is int number here in this case. Now when iterating through an array using the for each loop, the counter variable may be declared using the auto keyword. Instead of having it specified with its type, you just have to specify as auto. Now auto will detect which type of array is this. Now auto lets C++ deduce the type of the variable based on the type of the list it belongs to. So here's this example we're gonna run, and it's basically gonna do exactly the same thing. Over here 0, 1, 2, 1, 1, 2, 3. That's pretty much it. So another really important concept to know about the object-oriented programming paradigm is the 4 pillars of OOP. They're known as the 4 pillars of OOP, also as the 4 principles of OOP, also known as the 4 major benefits of object-oriented programming. So what are they? One is called encapsulation. Encapsulation is basically in object-oriented programming, or OOP for short. You bundle code into a single unit where you can determine the scope of each piece of code. So what does this mean is that you could basically bundle up your code into classes, and then you could reuse them, and basically that's encapsulating all that extra info. When you have your code bundled up into a single unit, like in a class, you bundle it up and use it as a single unit when you're instantiating it as an object, and then you could determine the scope of each piece of data. So abstraction is by using classes, you are able to generalize your object types, simplifying your program. And this is abstraction, meaning it's containing a layer so that you could not go into that more detail of how the function works, or how the methods work, or how everything is associated. Over here, inheritance, it says because a class can inherit attributes and behaviors from another class, you are able to reuse more code. So this is basically what we're saying, is that we could just inherit stuff from one class, and we could say that as the base class, and we could derive or extend another class from that existing base class, and then that's called inheritance. Such as an example, it would be an animal class, and something that is deriving from that animal class is like a dog or a cat. So the last one is polymorphism, and it says one class can be used to create many objects, all from the same flexible piece of code. Polymorphism in common words means many forms. When you create a class, you create as many objects as you'd like, and basically it's just as much as you want. So that's pretty much it. So now I would like to bring up the concept of multi-level inheritance. Now here we're gonna do it by using a piece of code. So I have my boilerplate, and right before this I'm gonna create a class. So let me just create a class, and what this class is gonna be is basically it's gonna be class A. Now class A has a public section, so it has an A attribute. We also have a constructor defined, so it's also in the public section, and it's just like this. And what it does is basically it prints out, so it just prints out constructing A. So we'll just put a \n here. Let me just copy this, and I'm gonna paste it over here, and I'm gonna paste another one over here. So we basically needed one importance here is that we have to put semicolons at the end. So over here as well. So let's zoom it in, and over here what we have is first is class A. This will be class B, and over here would have a small b over here, and then this will have a constructor B, and then we'd have a constructing B over here. So let me just have B over here, and over here we'll have C, and then we'll have a C over here, and would have the letter C here, and then would have something here. So constructing C. And now what we have here are three classes. We have A, we have B, and we have C. Now the thing here is we want to have B inherit from class A. So how we could do that, we could inherit that class using this syntax. So we put a colon, and then we could say public. So we could say public, and then we say A. Now this is basically inheriting all the stuff from A to B. And now if we want to inherit stuff from B to C, we could say colon, and we say public. So we say public, and we say B. So over here we have class A, which is the base class. Here we have class B, it's a derived class, and it derives from the class A. And then we have C class, which is deriving from class B, which is inheriting class A. So this is a chain of multi-level inheritance. Here I have to put a semicolon, and now inside of my main logic, I'm just gonna create one object. I'm gonna create one object, which is C, and it's gonna be called example. So C and example. Now what's gonna happen is that I created an object, the constructor of C will be called, and then there's a constructor of B, and then there's a constructor of A. So what do you think will be called first? In an inheritance chain, the most base class is always constructed first. The order of class construction then goes from the parent to the child. So first this will be called, then this will be called, then this will be called. So even if I have C constructed, I'm just gonna get this first, and then this, and then this. This is called multi-level inheritance. In an inheritance chain, a derived class inherits from all the base classes before it. Class C has all three attributes of A, B, and C because it is the last class in the inheritance. So over here in class C, we'll have every attribute. We have int C, we have int B, and we also have int A, since they're all public. So this C will have all of these attributes, will have this constructor as well. So basically the constructor will be called, most base class is constructor A, and then B, and then C, and that's how we got that result. So this is our result here. So constructor A was called, and then constructor B, and then constructor C at the end. So this is multi-level inheritance. All right, so now let's talk about member initializer lists. This example is going to be dealing with the concept member initializer list. So here we have an example of a class named book, and it has a private and a public section. In the private section, we have const standard string title, and we have const int pages. So it's a book, and it has its title and its pages. And in the public section, we have a constructor that has the title is equal to diary, and it has pages equal to 100. But notice that there's a red underline over here, and then there's one over here. What is this saying is that there's some errors going on. The first thing is that const variables can't be assigned to, and const variables can't be assigned to. Since they are const variables, it's not possible for the compiler to assign these to these const or any other variables. So far we have seen constructors that are assigning value to attributes and not initiating them. This subtle difference comes into play when dealing with const or reference variables, which must be initialized when they are declared. Using the regular assignment syntax for such types of attributes will definitely not work, and we could see this that it's not working here. So to solve a problem like this, C++ provides a way to initialize attributes via a member initializer list. And that member initializer list looks something like this. Basically, it's placed after the constructor parameters list. So this is the constructor, and then after this constructor parameter list, we have this placed after. So we have a colon, and then after that you could specify the title, which was over here. And since inside of these we have these parentheses and we put the double quotes inside, we put diary. And this is how we assigned title with diary as the default value, pages with 100 as the default value, and then we enclose, basically we end them with 2 brackets. Basically the member initializer list begins with a colon. Over here you can see that, and then list each attribute and the initial value for that attribute. So initial value for that attribute, and then the attribute here. Each attribute in the list is separated by a comma, and you can see that it's separated there. So this constructor will now work as intended because the member initializer list will properly initialize the const attributes instead of assign value to them. See this error over here that's saying something? So it's just basically saying declaration of a member with the same name as its class. So this is basically defined on the top. So if I just do control/, now this is commented and we have that error no longer existed. So remember to add these brackets at the end. And inside of these brackets, you can still add code to the constructor body. Now let's talk about some data structure concept. Here we're talking about sets, and I did do a video related to the STL sets that are available in the C++ language, and the one I'm going to be talking about here is basically the set, and it's included using the set header file. Here we're going to include it, so we're going to say set. Let's talk about the standard template library support for the sets in C++. So we can include the set using #include, then we write set. And we also have one other thing. So they're called unordered sets. So we could just include those as #include. So we can include those using #include, and we say unordered, and then we say set. So we could basically include that as well. So let's talk about how we can deal with these things. As the name suggests, an unordered set stores elements in no particular order. So the searching, inserting, and deleting an element from an unordered set is generally faster compared to the set. On the other hand, a set stores elements following a specific order and can be iterated directly based on the order of its elements. All right, so over here we have a set, and then there's an int data type to it, and we have an ordered name, and then we have this list inside which has 4, 2, 7, 1, 3, and then we have this as set. So this is basically the set, which is the STL set, and we're gonna check that we're gonna use a for each loop, which is gonna start with the first and go all the way to the last element. And you can see over here it's the ordered, so basically it's gonna go one at a time. Over here we have the unordered set, and basically look, the syntax looks pretty much similar to the set, but there's just a difference of unordered set, and over here it's just set. We have an unordered name and we put 42713, similar to what we did over here, but in this case we'll get something else. Over here what we're basically getting is a sorted form of the elements, and they're gonna be in ascending order. So this is the order of how the set is done, and then when we have unordered set, we have them in random order. Now this is compiled, and we have over here a set which is 1, 2, 3, 4, 7, which is an ascending, and then we have unordered set which is 3, 4, 2, 7, 1. Now what is preferred is the unordered set. This shows that set sorts integer elements in ascending order. And one important thing to note here, only use set when you need to store elements in a sorted fashion. Otherwise, use unordered set because it's generally faster. Talking about set and unordered set, now let's look at map and unordered map. Now, I have covered both of these videos out, the set STL and the map STL. If you guys haven't watched those, you'll see cards on the top right corner. So go click on those and watch those videos if you want to know more about them in detail. So we have ordered and unordered hash maps. So as the name suggests, an unordered map stores elements in no particular order. Searching, inserting, and deleting an element from an unordered, so this one over here, unordered map, is generally faster compared to a map. On the other hand, a map stores elements following a specific order of key values and can be iterated directly based on the order of its elements. So we have some code here, and we're going to demonstrate this out using an example. And we're going to see which one is generally faster. And of course, the unordered map will be faster since it is not in order. So over here we have the hash map, and we basically have the standard map. Inside of we have a key and a value pair. So int for the key, value will be a char, and then the name ordered. So here we have an initializer list which has 2 as the key and B as the value, which is a char, 1 as the key, A as the value, 3 as the key, and C as the value, and then there's declared over here. Now over here we have a for each loop. So we have this auto keyword which is going to be determining what this type is. So ordered has this kind of random type, so we use this auto keyword, and this it, suppose that is like an iterator. So we have a standard cout, so we have it dot first to access the key and it dot second to access the value, and we're going to go one by one. Over here we have the unordered map, and we have this int and char, and this is called unordered. So we have this initializer list putting values inside 2 and B, 1 and A, 3 and C, and we use the same thing, and we basically for loop, meaning iterate through it and get our values out. So I'm gonna have this, and now I'm gonna run it. Now over here we have the first case, so we have that key and then the value, key, and then value, key, and value. So you can see over here the first one was an ordered hash map. So basically we just call it a general map, hash map. So basically it sorts out the keys in ascending order. So you can see 1 2 3, and over here we specified 2 1 3, but over here it compiled to 1 2 3, so it's in ascending order. And for the unordered map we have 3 2 1, and this is in some random order because over here we had 2 1 3 and it just came out as something random. So only use map when you need to store elements in a sorted fashion. Otherwise use unordered map, this one, which is right here, because it's generally faster. Thank you guys for watching this video. I hope you learned something new. So recently I created a Patreon page for Coding Cleverly, so if you guys haven't checked that out, I would encourage you to go and check that out. So you could support my work by being a patron on my Patreon page, and always remember to like this video as it helps more people find this video out on YouTube. And until then, peace out.